problems that would happen is people would get goiter, okay, because they didn't have enough of that iodo part, okay. So now we know that. Hopefully thyroid gland functions good, but not always, because we can have people have problems. Now what it will do, if it's being used, hopefully it increases metabolic rate. Metabolic rate is based upon your consumption of oxygen use. Okay? That's what metabolic rate is. The quicker your body uses oxygen, which I'm not sure if you guys remember, but the only use of oxygen in the body is making ATP, cellular respiration, mitochondria. Does everybody remember that? So, increasing oxygen use, which would affect metabolic rate. So the goal is that as we have foodstuffs come in, as the body's making demands, this hormone helps cells meet that demand. Now, this part of this gland, in the cells of this thyroid gland, if this is being called a follicle, if this is being called a follicle, I have some cells now that are parafollicular. Para means what? Do it right? Para means around, okay? And so parafollicular, all right? So that means cells that are around these follicles. Secrete calcitonin. Now, did anybody know that your thyroid gland secreted a hormone that is going to act on your bones? Calcitonin. Okay, when you were learning about the skeletal system, okay, do you remember the cells of osteocytes, osteoblasts, osteoclasts, osteochondral progenitor cells? Yes, no, maybe. Okay, and then if we're thinking about bones, yeah, okay, my dog bone. All right. Remember how we had osteons, all right, with the canal down through the middle of it, and it had the concentric circles, and in that osteon, I'm going to kind of draw it right here, okay, where you had the central canal, then you had the concentric circles, and those concentric circles, once we had an osteoblast, which is laying down the bone, secreting the hydroxyapatite, okay, it would get stuck, and it was now referred to as an osteocyte, And then we could get the cells that were called an osteoblast that could break this hydroxyapatite, which is the hard part of the bone, down. Does everybody remember that? Do you remember what the formula was for hydroxyapatite? Hydroxyapatite was calcium phosphate. So if it was an osteoblast, it was secreting it, making the bone hard, and then getting stuck to become an osteocyte. Then if I needed calcium or phosphate in the body, the osteoclast would break it down and release calcium and phosphate. Please tell me you remember that. Why is that process so important? Here's how. Okay, here's the perfect example of why we have to think outside the box. Why are calcium and phosphate important in the body? The bone, believe it or not, the bone is strictly my storage site for it. Because if I do not get a proper amount in my diet, my body is going to recognize that the blood level, for example, of calcium, is incorrect. And it will go to the bone to get it. What do you happen to remember one of the cells of the body that is heavily dependent on calcium? Muscle cells. Hold up. What muscle? Skeletal, smooth, cardiac. What muscle cell that he just mentioned is 100% active all the time? Cardiac. If I don't have enough calcium, if it's too much, too little, that cell will not function, possibly to the point of death. How did I just get you to think outside the box? How many systems did you just now put together on that one piece of information? Endocrine, skeletal, muscular, cardiovascular. Trust me, more is involved. I know you're thinking, why does she do this? I know that. I've sat where y'all sat and have been like, holy cow, she don't stop talking. Why would this be clinically significant?
Maybe if someone's calcium deficient, have other issues.
They're going to have other issues. They're going to present with other parts of their body showing signs of something being wrong. And so if they go to do the lab work, those of y'all who are in my field already, do y'all get to see lab work? Are you not dependent upon it? Are you not dependent upon it? And why?
Because he said he was going on.
It is, I wouldn't say the basis, but it is so important. And to understand what that lab work might be telling you, you've got to put this type of stuff together. Yes, no, maybe. So now, did you happen to know that the thyroid gland does this? Because it's not something that we would usually think about. When we hear thyroid gland, we tend to associate that thyroid hormone, and we tend to think hypothyroidism, hyperthyroidism, okay? We don't begin to even think about the bone. So, in this gland, based upon its structure, we can see that these parafollicular cells get information about levels of calcium in the blood. If they get information that the calcium level in the blood, and let's do this as our blood vessel, okay? And let's say calcium levels are high. They are going to secrete calcitonin. The reason that we would want to affect the calcium level in the blood, if too much calcium is present or too little is present, and because it acts not just on muscles, it acts on nerves, it can either make either one of them too active or not active enough. For example, too active, if I go back to thinking about, I don't know about you guys, but I kind of like the fact that my heart beats, okay? And that I don't have to really pay attention to it. Because trust me, if I had to pay attention to it, I'd be in trouble, okay? So I kind of like the fact I don't have to pay attention to that. So if there's too much, which would affect the beating of my heart, or too little, which would affect the beating of my heart, okay? My body says, oops, let's take care of this. So if it's too much, it will simply say, oh, hey, osteoblast, do your job. Come on now, lay down that hydroxyapatite, which is calcium phosphate, which would pull the calcium from the blood and put it into the bone. And bada bing, bada boom, I balanced the calcium in my blood level and my heart hadn't gone crazy. Personally, pretty cool. Questions? Done?